Hello everyone, this is Griffin Kindred, and today I'll be doing my Project 2 video. So for the shape I will choose, I will just do the flat plate and demonstrate the entire project using the flat plate. So first thing I need to do is, here is the wind tunnel from Project 1. And the first thing I need to do is draw the flat plate onto the wind tunnel. Okay, for the dimensions, I'm making the height 5% of the test section height for the blockage ratio, so 0.3 inches, and then the width will be 0.05 inches. As we can see, it's very off-center, but don't worry, we can fix that. There we go. Okay, now we are there. We can create bowling, which is what we're going to do for this. Let's get rid of this. There we go. Now we will you know what? Okay. There we go. Now we can make there we go. Okay. Use subtract, target bodies, tool bodies, and there we go. We got our outline there. Let us generate, and we're done with geometry. Next step is mesh. Going to pause this and one pause when it is ready. Alright, there we go. Okay, now onto the mesh. We can see this needs to be let's generate. We can do the triangles method, but just for the sake of the video, I'm just doing the regular default method of creating our mesh. And I will actually unpause when it is ready. Alright, now we have our mesh created. As you can see, here's a little flat plate. We have our new mesh, so we're going to close out of that. And we are going to update. Alright, we're back. We got the mesh load. Now we're onto the results tab. This is where we're going to get our contours and our drag forces. Alright, so with a 50 hertz boundary layer. Oh, you know what? I forgot to do one thing. Sorry about that. Forgot one thing to do. Since this is a brand new project, I forgot to create the inlet, outlet, and walls. So we have the inlet. The outlet, the ton walls, and of course we'll call this flat plate. There we go. Alright, there we go, we're back. And now we will do our reference values. The inlet. Oh, whoops. Let me make the boundary layer real quick on this. I believe with 50 hertz, we plug into the equation, we get a 1.3415 meters per second with a 50 hertz. Now, this is what we get with the equation that he used for project 1. There's a bunch of different things people are saying, but this is what me and my partner Ryan Baker chose. So that's what we went with. So now with the reference values, if I select inlet, there we go, velocity is the same. Just to make sure, we want to make sure the no slip condition applies. Very good. Okay, just had to make sure. And residuals, we're going to bump this down. So sometimes the iterations will converge with a lot less iterations. Anyway, now I will initialize. I will pause the video, and then when it's done initializing and calculating, I will return, because it just, with the recording software, it has a hard time doing the calculations. So I'll be right back. All right, we're back. We have calculated our mesh, and now we are able to get the contours that we desire. First one is static pressure. So we're going to compute, we're going to display it, and as you can see, we have our static pressure contour that we are looking for. The next is to find the velocity, and it's the same exact thing. And as you can see, here's our velocity contour with a flat plate. Obviously, we do this 3 other times with 3 other objects being hemispheres, but 2 facing different, or both of them facing opposite directions, and then a NACA, which we use NACA 0012. Okay, now for the streamline, actually before I do the streamline, just to show how to get the drag force for our wind tunnel, for the flat plate, all we do is we go to force report, drag force, flat plate, compute, and as you see, we have computed a 0.302 drag force, which we will then use to calculate the drag coefficient using the equation. And lastly, the thing we needed to find was the streamline. How we found it was by going into the solutions tab, or no, excuse me, the results tab. I'm just going to pause, and I'll unpause when I have it open, so this Fluent will start running again. Alright, so we are in the, as you can see, we are in the results tab of the workbench, and basically all we need to do to get our streamline is up here at the top. There is a streamline button. We'll just call it streamline 1. We can do as many points as we want. Let's just say 40 points, equally spaced. Apply. Give me 1 second. Okay, we're back. And sorry about that, just wanted to check that I updated. And then as we can see, again, we go to the streamline at the top, press it, it opens up this detail sheet. We start from the inlet, we want 30 points, equally spaced, apply. And as you can see, we have a very nice looking streamline. And this is what we will take our picture. We can make it as many points as we want. If we want a little more accurate data, we could also have used in the setup. There's another way to get streamlines, but we found it not as user friendly. It really wasn't giving us what we were looking for. We wanted a nice smooth lines, so this we found was the best way to do it. And that is all of the data that we collect, and that is how to collect it. So thank you very much for watching, and I hope you have a good rest of your day.